Good morning, students. So today we are going to discuss about the chemical properties of carbon. So let's start. Chemical properties of carbon. The first topic is combustion. So some typical reactions of carbon which we are going to study in this class. So reaction of carbon with oxygen. Okay, you know combustion means what? It is burning only, no? Anything burns in presence of oxygen. So combustion tells us about that only. That any substances burns in the presence of oxygen. So carbon also, if it burns in excess of oxygen, in plenty of supply of oxygen, with a sparking flame, it forms carbon dioxide. So you can see C plus O2, plenty supply of oxygen, it will form carbon dioxide. But for limited supply of oxygen, if you supply, a very limited supply of oxygen is present, then what it is forming? It forms carbon monoxide. So carbon plus O2, but this time limited supply, it burns to produce carbon monoxide, heat and light. Okay. Now this carbon monoxide is a poisonous colorless gas. Okay. Now this carbon monoxide is very and extremely dangerous. Okay. Why? Because if you inhale, it combines with hemoglobin which is in your blood to form carboxyhemoglobin. Means this carbon monoxide plus hemoglobin, it forms carboxyhemoglobin. This carboxyhemoglobin cannot carry oxygen. Okay. This causes a deficiency of oxygen in your body, in the tissues. So, if it produces or if it causes deficiency of oxygen, it results in suffocation. And it is very severe. It even causes death. So, it is due to this reason we are not advised to sleep in a closed room with a coal-fired place. Okay, like we say, angithi inside. So, that is why on a cold wintry night, it is not advisable to sleep in a closed room with a coal-fired fireplace. When the room is closed, no fresh air can enter the room. Initially, what happened? Burning of coal would consume whatever oxygen is present inside the room. That will consume, means here limited supply of oxygen is there. And hence carbon monoxide formed. So when this carbon monoxide formed, it is dangerous. So that is why it is suggested not to sleep in a closed room with a coal-fired place. The second chemical property is reducing property. This is a very good reducing agent. Carbon is a strong reducing agent. It reduces metallic oxides to corresponding metals. That means metallic sulfides to sulfides and water to hydrogen. These reactions occur at high temperature. You can see here it reduces copper oxide to copper. What happened? Metallic oxides to the corresponding metals. So it is a very good reducing agent. Few more examples are given of lead oxide and hematite. Hematite means iron oxide. No. Fe2O3. Now this hematite reacts with carbon monoxide also, and when it reacts with carbon monoxide, it again reduces to iron and carbon dioxide. In the first example, in the first one, that is hematite, when reacts with carbon only, it forms carbon monoxide. So this is how carbon reduces, carbon acts as a reducing agent. Let's study the allotropic forms of carbon. So what is this allotropy? Allotropy means the existence of an element in more than one forms. Means if an element is present in more than one forms, we call it allotropy. The various forms of an element which have similar chemical properties but different physical properties. The different forms are called as allotropes. same, you can see chemically same but different physical properties are called its allotropic forms. So allotropic forms are also called allotropes. Diamond and graphite are two allotropes of carbon. We will study as we discuss this topic further. The difference in physical properties such as electric and thermal conductivity of the allotropes is due to their different structures. We are going to see its structures in the coming slides. You see allotropic forms of carbon. Now there are two forms of allotropes. There are two allotropic forms of carbon. So I think that allotropy is clear. The property of which an element can exist in more than one forms is called allotropy. Now, the allotropic forms of carbon, it can be classified into the following two categories. One is crystalline forms and the other one is amorphous forms. In crystalline forms means what? You see, diamond, graphite and fullerenes are the crystalline form of carbon. Okay, these are the purest form of carbon. What about amorphous forms? You can see coal, charcoal, coke, lamp black, carbon black, etc. Many things are given here in the book are the amorphous allotropic forms of carbon. Okay, so the classification of the various allotropic forms of carbon, you can see in your book. It is given that carbon, the two arrows are there, crystalline forms and amorphous forms. In crystalline form, diamond, graphite, fullerenes, and in amorphous form, coal, lamp black, gas, carbon, carbon black and charcoal. You see the pure form of carbon, fullerene, diamond and graphite. You see the structure of fullerene is also given. So diamond is one of the purest crystalline form of carbon. The number of carbon atoms in any piece of diamond depends upon its size. Okay, and you can see the formula is Cn, where n is a very large whole number. Commonly diamond is represented by its empirical formula. Okay, now you just study the occurrence that where diamonds are found. Remember this one. South Africa is the largest producer of diamonds. In India, diamonds are found in Panna mines, that is in Madhya Pradesh, and Vajrakur Karur, that is in Andhra Pradesh. Okay, now let's just study about the properties of diamond. So you can see the properties. In diamond, each carbon atom utilizes its 4 unpaired electrons in bond formation. Okay, you just leave this one. Appearance, you know that it is a transparent substance having high refractive index. Properly cut and polished diamonds shine and show extraordinary brilliance. It occurs as octahedral crystals. Okay. Now, hardness, you know that it is the hardest natural substance known. Density as high, it has high density. Diamond is it is a non-conductor of electricity. As you know that it is what? It is a form of carbon. Carbon is a non-metal and non-metals are generally non-conductor of electricity. Diamond is a non-conductor of electricity. That is, electricity cannot pass through a diamond. Thermal conductivity, in this, diamond is also a non-conductor of heat. Solubility, diamond is insoluble in all known solvents. Air has no effect on diamond at room temperature. So when heated in air at 900 degrees Celsius, it burns to give carbon dioxide. Means it has no effect at room temperature. But when if you heat it at 900 degrees Celsius, then it will give it carbon dioxide. So structure of diamond, you can see I am showing you. In the book also it is given that structure of diamond. Each carbon in diamond is bonded to 4 others in tetrahedral arrangement. So each carbon atom is covalently bonded to 4 other carbon atoms in a tetrahedral fashion. This tetrahedral arrangement of carbon atoms gives a rigid 3-dimensional structure of diamond. Okay, this is rigid. So it is due to this reason only diamond is very hard. It has high melting and boiling point, and it is a non-conductor of heat and electricity. So remember this one. Now let's see the uses of diamond. You know, diamonds are used as very precious stones. It is very precious stones in jewelry. Diamonds are used for manufacturing tools, for cutting and grinding glass and rocks, and making dyes for drawing very thin wires of harder metals. There are more uses of diamonds. Just learn this uses of diamonds. It is important. So pure diamond is colorless. Due to impurities, it may be colored. Okay, now let's study about the graphite. Graphite, its structure you can see, it is also known as black lead because it marks paper black. Graphite is another crystalline allotropic form of carbon. Its formula is also Cn, where N is again a large integral number. The value of N depends upon size of the graphite crystal. So in common use, graphite is described by the symbol C. Okay. So you just remember the occurrence also. This is also important, as it is generally in India. It is found in Odisha, Rajasthan, Bihar, Jammu, Kashmir. In USA, Canada, Sri Lanka, Siberia, it is also found extensively. Then graphite is also prepared artificially by heating anthracite coal with a little iron oxide or silica in an electric furnace. So you can see that if you take anthracite and if you heat it in an electric furnace as a catalyst, you will get graphite. So now let's see the properties of graphite. Graphite is a grayish black. It appears grayish black opaque material having shiny luster. Okay. Graphite occurs as hexagonal crystal. You can see the hexagonal crystal 1, 2, 3, 4, 5 and 6. 6 is there. So that is, it is a hexagonal structure. Now, hardness, it is soft, having a soapy touch. Okay, so it has a slippery touch. So it is soft. Carbon is non-metal, it is soft. Okay. Graphite is lighter than diamond. The density of graphite is, it is given 2.3 gram per ml. Okay. Then it is a good, see this, what I am telling you is this only, that these are the two allotropes. These are the two allotropes. One is graphite and another is diamond. These are the two allotropes of carbon only. But diamond is a bad conductor of heat and electricity. But graphite is a good conductor of heat and electricity. Graphite has a very high melting point. Graphite is also insoluble in all common solvent. It burns in air at 700 to 800 degrees Celsius. But there, diamond burns at 900 degrees Celsius to give carbon dioxide. Structure of graphite, you can see, I am showing you here that in graphite, carbon atoms are arranged in flat parallel layers. You can see each carbon atom in these layers is bonded to 3 others by covalent bond, forming a network of 6 carbon rings. The 4th valence electron of each carbon is free to move. So the structure of graphite is shown here. You can see it. Now there are some of the uses of graphite. Learn this, the uses of graphite. You know that it used in lead pencil. It is used as a lubricant. It is used as an artificial diamonds. Okay, and there are furthermore uses are given. Just remember. So this diamond and graphite topic is finished. We will learn in the next class the properties of fullerenes, and I think that's it. One more uses are there. We will discuss that, the uses of fullerenes, and then we will conclude the uses or the allotropic forms of carbon. In the next class, we are going to discuss about difference between diamond and graphite and the amorphous forms of carbon, the more amorphous forms of carbon. Okay. So till then, you study. Thank you so much.